All right, today we're diving into the pretty incredible world of genitourinary pharmacology. We're going to find out how these really cleverly designed drugs can manage some of our body's most fundamental jobs, from keeping all our internal fluids perfectly balanced to controlling the massive power of a muscle contraction. Let's jump in.
It really does sound like something out of science fiction, doesn't it? The whole idea that one little pill can take command of these huge biological forces. Well, the secret to how it all works is in understanding and then, cleverly manipulating the body's own super complex control systems.
So, our journey today kicks off with the genitourinary system. You can think of it as the main command center for all the critical functions we're going to be digging into.
So, what exactly is the genitourinary system? Well, it's basically two interconnected systems rolled into one. First, you've got the urinary system. That includes the kidneys, and its whole job is filtering out waste. Then you've got the reproductive system, with organs like the uterus. We're going to look at drugs that target both of these.
Let's start with the urinary system and really zero in on the kidney. A fantastic way to picture how it works is to imagine it's a giant, super sophisticated water park.
So, picture the kidney's main functional unit, it's called the nephron, as this amazing winding water slide. But it's not just for fun. It's a high-tech sorting facility, and its job is to meticulously separate what the body needs to keep from what it absolutely has to get rid of.
Okay, so in principle, the process is just brilliantly simple. First, the kidney just filters pretty much everything out of the blood. Next, it pulls back all the useful stuff, especially salts. We'll call them our salt passengers. And finally, and this is the absolute key, water automatically follows those salt passengers right back into the body. It's just simple physics.
This right here is the golden rule of how your kidneys work. You have to remember this because it's the fundamental principle behind how almost all diuretics work. If you can control the salt, you control the water. It's that direct.
So if that's what's supposed to happen, how do we jump in and change things? Well, this is where diuretics come into play. They basically hack the water slide sorting system to change the final outcome.
Let's go right back to our water slide. Diuretics are like security guards that we post at different spots along the slide. Their whole job is to block our salt passengers from getting off the ride, from being reabsorbed. And if the salt is forced to stay on the slide, what happens to the water? It has to stay with it. The end result is a lot more water leaving the body as urine.
Now there's an important catch to this whole process. As all that salt and water are getting flushed out, another really vital passenger, potassium, often gets lost right along with them. And that's a big deal because potassium is crucial for your nerves and muscles to work right. While most diuretics cause you to lose potassium, there's a special class, like spironolactone, that are potassium-sparing, meaning they have a clever way of holding on to it.
This table kind of shows the different security guards we can use. Thiazides work late in the game, way down at the distal tubule, which makes them great for managing things like hypertension. Loop diuretics, they're the heavy hitters. They work on the main loop of Henle and are safe for emergencies like major fluid buildup. Then you have the K-sparing ones, working at the very end to save that potassium. And finally, osmotic diuretics are totally different. They don't mess with the salt. They act directly on the water itself.
Okay, so we've seen how these drugs can control the flow of water. Now let's totally switch gears. We're moving from the urinary system to the reproductive system, where the challenge is completely different. Now we're talking about managing the control of uterine muscle.
Yup, we are leaving the water slide far behind. The new goal isn't to manage tiny little salt passengers anymore. Now it's all about controlling the incredibly powerful, smooth muscles of the uterus. This is a game of managing immense force, not fluid.
Luckily, the pharmacology here is actually pretty easy to boil down to a core idea. When you're trying to affect the uterus, drugs are basically designed to pull one of two levers. You either relax the muscle or you contract it. Simple as that. And here you can see those two opposite goals in action. To stop premature labor, which is so critical for giving a baby more time to develop, a drug like Ritodrine is used to relax that uterine muscle. On the flip side, to get labor started or help it along when it's medically needed, you use drugs like oxytocin or ergotamine to trigger powerful contractions. Two totally different goals, two totally different types of drugs. So how do these drugs pull off such opposite effects? Well, they're targeting completely different biological pathways. Ritodrine is what we call a beta-2 agonist. It basically flips a switch on specific receptors that tell the muscle to just stand down and relax.
Oxytocin, on the other hand, floods the muscle cells with calcium, which acts like the direct trigger, the spark plug, that ignites a contraction. And ergotamin is a bit more of a blunt instrument. It causes a more general constriction of smooth muscles.
Wow. Okay, we've covered a ton of ground, from kidney water slides to the immense power of uterine muscles. So to make sure this all sticks, let's wrap it all up with a quick field guide, the key takeaways you need to remember.
First up, a little trick for remembering the uterine drugs. If you need to delay labor, just think relax with Retrodrin. That shared R is a super simple but really effective way to link the drug to its vital, time-buying job.
And for the other side of the coin, for inducing labor, just remember that contractions are fueled by calcium. This is a great way to remember that oxytocin's main trick is boosting those calcium levels, which provides the spark for those powerful muscle contractions.
And finally, let's circle all the way back to the single most important thing for understanding diuretics. If you only take away one thing today, let it be this golden rule: where salt goes, water follows. That is the master key to understanding how our bodies and these drugs manage the entire fluid balance. I mean, it is truly incredible when you stop and think about it. We've developed these molecular tools that can go inside our bodies and act like tiny security guards or muscle controllers. That shows an amazing level of control, which really just leaves us with one final thought. If we've already achieved this level of precision, what comes next? What system will we learn to control tomorrow?